We now prove this trigonometric equation as an identity. That is, on the left side, we have sine x plus y over sine of x minus y. And this equals, on the right side, we have this expression tangent x plus tangent y over tangent x minus tangent of y. So first, let me consider the left side expression. That is, we have sine of x plus y over sine of x minus y. And now I'm going to use the sum and difference identity for sine function. So in the numerator, I use the sum identity. So we can expand this as like this. That is sine of x plus y equals sine x cosine y plus cosine x and sine y. And then let me expand the denominator expression. So this equals, that is sine of x minus y equals sine x cosine y minus cosine x sine y. The next step, I'm going to divide both the numerator and denominator by the term cosine x cosine y. So this is the numerator term, and this I'm going to divide by cosine x cosine y, and also the denominator term I'm going to divide by the same term, that is cosine x and cosine y. Now we can rewrite both the numerator and denominator terms as a sum or difference of two terms. That is as like this. Let me write down. That is, we have sine x cosine y. Since we are dividing by cosine x cosine y, we put this as divided by cosine x cosine y, plus we have cosine x sine y, and this is also divided by cosine x sine y. So this is the numerator fraction, and this is all over by the denominator fraction. And this terms in the denominator fraction also we divide by cosine x cosine y, which can be rewritten as sine x cosine y, the first term, divided by the divisor, that is cosine x cosine y. We then have minus, then we put cosine x sine y, and this is also divided by cosine x cosine y. It's just that we have rewritten the same fraction as a sum or difference of two fractions. Now we can use this quotient identity, that is sine x over cosine x is, I'm sorry, this is sine x over cosine x, and this is identical to tangent x. So wherever we have this quotient, we can replace that as tangent x, or if we have sine y by cosine y, we can replace them as tangent of y. So we can see here sine x over cosine x. So this equals tangent x. We then have cosine y and also cosine y. So these two gets cancelled. And in the next term, we have cosine x, cosine x. These two gets cancelled. I'm sorry, this has to be cosine y because the denominator is cosine x cosine y. So let me put cosine y here. And we now see that we have this quotient as sine y over cosine y. And this equals tangent y. Now let's verify the denominator terms. We have cosine y, these two gets cancelled. And we have sine x over cosine x, and this equals tangent x. We then have cosine x, these two gets cancelled, and we have sine y over cosine y, and this equals tangent y. So we have the numerator tangent x plus tangent y. So I write tangent x plus tangent y, and in the denominator we have tangent x minus tangent y. Tangent x minus tangent y. And this is exactly equal to the right side expression, that is tangent x plus tangent y minus tangent x minus tangent y. So we see that this trigonometric equation is an identity, and so we thus proved that this left side expression sine of x plus y over sine of x minus y equals tangent x plus tangent y over tangent x minus tangent y.